Good morning, good afternoon, and good evening. This is Mr. Payne bringing you Unit 1, Lesson 8, Complex Equivalency. We should now have a better ability to work with exponents. In this lesson, we will continue to explore expressions that are equivalent but look different. We will be primarily sticking with linear expressions, those where x is only raised to the first power, and quadratic expressions, where x is raised to the second power. Recall that two expressions are equivalent if they return the equal values when values are substituted into them. Exercise number 1. X minus 2 times x plus 5 is equivalent to one of these expressions. Determine which by substituting in a variety of values to test it. So the values that I would like you to use are going to be 1, 0, and 2. I'm going to do the first test with you, and then you are going to complete the others before you come to class. So I'm going to use x equals 1. So wherever x is, I'm going to put 1 in there. So 1 minus 2 times 1 plus 5. 1 minus 2 is going to give me negative 1. 1 plus 5 is going to give me 6. Negative 1 times 6 is going to give me a negative 6. I'm going to plug 1 in for the next one, so it's going to give me 1 squared minus 10. Well, 1 squared is going to give me 1. 1 minus 10 is going to give me negative 9. And the last problem is going to be 1 squared plus 3 times 1 minus 10. 1 squared is just 1, plus 3 times 1, which is 3, minus 10. 1 plus 3 is 4. 4 minus 10 is going to give me a negative 6. Please recognize that negative 6 and negative 6 come up in those two expressions. So as of the first test, x equals 1, these two would be equivalent. Why are they equivalent? Because when I plug in x equals 1, I get out negative 6 and negative 6. This proves that those two equations are equal, or those two expressions are equal. Now I would like you to try 2 more tests to make sure that those two are equivalent. Please test 0 using N2. We're going to switch gears a little bit and talk about multiplying binomials. Keep in mind that you are simply doing the distributive property twice. So we're going to take these two expressions, these two binomials, multiply them together to get a trinomial. So what I'm going to do is take the x, and I'm going to pull that out of this first binomial. So I'm going to have x times x plus 3. Then I'm going to take the plus 6 out and multiply that by x plus 3. That's why the directions say we're going to do the distributive property twice. So in red I have x squared, because x times x gives me x squared, plus x times 3 gives me 3x. 6 times x gives me a positive 6x. 6 times 3 gives me a positive 18. Noticing that my terms in the middle are like terms, so now I can go ahead and combine those. Nothing to add to x squared, so it just gives me x squared. 3x plus 6x gives me 9x, and then plus 18. With example B, I'm going to show you a second method that you can use that I often like. I'm going to call it the box method. You're going to draw a box, divide it into 4 quadrants. X minus 4 will go up on top, and then x plus 6 will go on the side. Now all you have to do is multiply x times x, and that's going to give me x squared, x times negative 4, which is going to give me negative 4x, x times 6, which is going to give me 6x, 6 times negative 4, which is going to give me negative 24. Notice here, my terms in the middle again are exactly the same. They are like terms. So I can go ahead and write my final answer by taking x squared out of the top, 6 minus 4, which gives me positive 2x, minus 24. We solved B by using the box method. I would like you now to try examples C and D using whichever method you would like, either the double distribution or the box method. Now I'd like to jump to example example E. I'm going to show you double distribution again for this. I'm going to take the 3x out and put it out in front. So 3x times 3x plus 2. I'm going to pull the negative 4 out and put that out in front. Three x times 3x gives me 9x squared. 3x times 2 gives me a positive 6x. Negative 4 times 3x is going to give me negative 12x. And negative 4 times 2 is going to give me negative 8. Positive 6x and negative 12x now can be simplified. You're going to get negative 6x. So I have 9x squared minus 6x minus 8. I would like you to try now example F on your own. You should be coming to class with C, D, and F completed so that we can take questions and go over answers the first thing we do in class. The last exercise we're going to do today is exercise number 4. Jeremy has noticed a pattern that he thinks is always true. If he picks any number and finds the product of one number larger and one number smaller than it, the result is always one less than the square of this number. So the most important part of this this little sentence here is if he picks any number and finds the product of one number larger, so product of one number larger and one number smaller than it. Let's stop right there. I'm going to underline the other one in red. The result is, that's important, always one less than the square of his number. So let's do some sampling. Let's call this, let's do our first test, and I'm going to say the first number I choose is 2. So if my first number is 2, we're going to look for one number larger than it, which is 3, and one number smaller than it. The word product means that I'm going to multiply those two together. The words the result is, it means equals, one less than the square of his number. So the square of his number would be 2 squared. Less than means subtract 1. So we're going to do this math problem now and see if they're equal. 3 times 1 is 3 equals 2 squared minus 1. So 2 squared is 4 minus 1 is 3. Does 3 equal 3? Yes, it does. So the test does work for this number too. What I would like you to do is pick another number. I would like you to pick a number and try it out. Once you conclude testing exercise 4A, I would like you to do exercise 5 on your own and come in with any questions or problems you may have. At this time, please write your WSQ and be prepared for class. Please remember that if you have a problem with problem C, D, F in exercise number 3, or a problem with exercise 4A and doing a test on your own, please feel free to send Ms. Bell, Mr. Orgak, or myself a post on Edmodo. If you send your teacher a post, they will be able to answer it and get back to you before class, or be prepared to answer it in the beginning of class. Thank you and have a great evening.